This showing you how to do some basic segmentation of a pelvis scan in Materialise Mimics. So first thing you're going to do is create a new mask under the Segment tab, and you'll see that we have a preview here of our pelvis, and the slices are kind of thick here, about maybe 2mm slices. Hit OK to create that mask. And the next thing we're going to do is a split mask. We can actually see that this pelvis has a tripod fracture in it because there's fracture lines right here on the medial side of the acetabulum. All right, so we're going to do a split mask. And if we count the number of total parts here that are separate bones, we've got femur, we've got the ischium, which is actually separated here. So we've got 1, 2, 3, the sacrum is 4, other ilium's 5, 6, 7 pieces total. So we can just add some more of these masks. 7 total pieces. I'm going to start from the top and click region A and just highlight this. Region B will be the ischium. I can hold Control, left click, and drag left, which will shrink my brush size. So I can do that. On the Mimics 25 version now, we can start to do the split mask in 3D as well. So I could just paint on here. Right, then go to my next region, ilium, and we want to help the computer basically figure out where are the separation points between these. So this model is pretty easy. We don't want to miss any floating pieces. So for the sacrum, make sure we get all those. We're helping it figure out where to split these bones apart. So it's really important to, if we have masks that are kind of like touching, are very close to touching other pieces, we want to identify those edges in this. So you can see between these two fracture points, the mask can touch in a couple places. So we just make sure that it's differentiated with that brush. And our last one is this femur. All right, so then we'll watch the magic happen on our 3D right here. We can do a full screen by hitting spacebar while our mouse is over that screen. Then we hit OK. And all our pieces are separated. So we could get rid of our original mask and just work on each of the pieces now. Our next big task is usually to fill in these bones. So I'll show you how to do a couple, and then we'll skip to one that's already filled in. So typically we do this with a smart fill command. And we're going to, especially on these long bones, these diaphysis of the bone is not going to fill in with this automatic fill holes tool. So we'll go to the bottom of our axial views and do mark hole, and Control right click and dragging up is zooming in here. Just mark that. Then we can go on our other images and we can mark where those edges are. Scroll through our images, check that we're getting all the holes filled in. You can also check on our 3D and see, make sure that the holes are getting filled. You can also use some wrap functions after this. I'm not super concerned about that. Smart fill with our next bone. I want to make sure that we don't use this auto filling tool, because if we do that, it's going to fill in this fracture and we don't want that to happen. So we'll just click cancel here. And we would use the smart fill, but we'd use only this mark hole tool. Make sure that that doesn't get filled in. We can skip 10 slices at a time with the page up, page down button on the keyboard. So that helps us kind of skip through these really quickly and mark these holes. And as you get more familiar with the bones, you'll see some common areas on bones that might have thin regions of bone and might not get filled automatically. All right, so we'll just go really quick and do that. Sacrum is probably one of the hardest bones to fill in because there are so many natural holes in it for nerves. And so you just kind of see that, and it's helpful on the 3D if you see that is the region D. You can see on the 3D where the holes are supposed to be and where they're not. So that'll take a little bit more time to fill in. And you want to make sure not to do this, not to mark on the outside of the bone. If we do that, that becomes much harder to clean up after the fact. So just take your time and make sure that these holes still exist at the end of your segmentation. All right, now let's get to the one that's filled in so you can see what's next. All right, so here's one that's filled in. So basically what you notice is every time I did that smart fill, it generated a new mask, and that one was filled in. So we want to name those as the name of the bone. We can delete the original region A through G or A through F, whatever we had. You can do some final cleanup here. So you notice here's the fracture line and that bone, and see there's some gaps, maybe in this part of the bone here. So you could fill it in. That's a left issue. But if we just take that as a 3-matic, then that's easily filled. Even if we just do an auto fix on the bone, since it's porosity that's contained inside, we can also wrap with a very small amount. So these bones have been calculated into parts. So we just highlight all of those, right click and do calculate part. That will put them down here. We've done a smoothing operation in here as well through 3D tools menu, and you can do a reduce and a smooth if you want to. Not necessary. You can just hit Control C once you've got those objects down here, and you can just highlight all of these. Just check off your parts, click OK, and click over here in your object tree. You'll see that's highlighted, and just Control V to paste them. So there's all your bones. You can highlight them all and make them a bone-like color. That will turn it on a bone color. If we're 3D printing this, we want to do a couple more operations. We want to kind of smooth out the surface a little bit. We see typical areas that are difficult to get smooth are around the femoral head. So do a quick highlight all these, do an Alt-R, which is reduce, and you do a small amount of error. And then Alt-S would be a smooth operation. And then we can see how that fixes geometry a little bit. If that's too smooth, then you can do a little bit less, because you can do the operation more than once. If you want to smooth this segmentation defect out, even like how this is connected here, you could do Alt-T is trim, and this is the left finger. And we just take out this piece here. And S is shortcut for local smoothing. We do selection only. We'll make sure that our expert mode is on. If you don't see some of these parameters, that might be the issue. So make sure expert mode is on down here. We have selection only checked off. We can then click the bone surface, put our diameter up at something reasonable, and we could just kind of click away these segmentation artifacts. And we know the femoral head is extremely smooth because it's that articular surface. So we can really smooth that area quite a lot to be anatomically accurate. That's kind of how we clean up our parts. If we want to look for porosity in those parts, we can make them transparent. We can look for those areas that might kind of be hidden to us normally. And you can do a small wrap function on actually all of these. if you look at how big is the hole that's on the surface, like that hole might be kind of big, but these holes are really small. A wrap function of a very small amount will not fill in these cracks. So we could do that through design and wrap, or fix and wrap. The difference between those two is design can add some additional thickness, whereas the fix wrap is only going to add whatever thickness it needs to close the holes. So let's say a hole of 1.5 and smallest detail of maybe 0.4. The smaller you go on this smallest detail, the higher amount of memory it's going to take, the longer amount of time. So be careful if you don't go over like 1 GB on here, as it could crash the software. If I hit apply on that, it'll make new parts for all the parts that are wrapped. Working through each of those. And what we can do is we can group all of these, say these are originals. And what you would see is a number of triangles and a surface area here. And what you can look at in this set is what's the difference in surface area. You can kind of see what's the difference in if we reduce our porosity at all. You could hide these and you could check transparency of these as well to see if it fixed that. So that fix those areas that we should have closed up in the last step. So it's okay, even if you miss a little bit, it's still work out with a wrap function. Color change, so we just have to change that back. And you can see that putting things in transparent is also a little bit more intense on the graphics, so things could slow down a little bit. So just be aware if you have parts that are a lot of triangles, and doing that could slow things down a little bit. Great. And then the next thing, if we're going to 3D print this, you want to kind of attach all these floating pieces together to make sure it prints all as one piece, if that's what you want. So under the design tab, we can do connections and do automatic between entities, select all parts. And then this will say what's the minimum radius of our cylinders that connect them. So depending on the printing technology, we might go from like a 4mm to 8mm diameter of this. And the maximum length would be like how far the cylinder can bridge between two parts. So nice. Like, well, what's the difference between the sacrum and ilium here? Probably centimeter max. And then so we do a little bit bigger than that. And then target distance is how far away from each other are the cylinders. So we'd say like maybe on a femur, we want at least 3 cylinders to touch all these parts. And that maybe we have to separate them each by 7 or 8mm to get them to have that many. So when we click apply, it'll create all those cylinders and put them in a folder for us. Each of those cylinders are separate parts. They're just grouped in a folder. And it's easier to delete cylinders than add them. So we could, if we want to delete them, the first thing I would do is Boolean them together. So Control B on that folder, new part, and remove original, click apply. This is nothing in that folder anymore, so delete that. And then these are all the cylinders. And what we can do now is hit F7, and if you wanted to delete any of these, then you can go through and select them. So maybe I want to delete this and this. So you can go through like that and just delete the cylinders you don't want. See that this part is floating but did not get connected. So one thing we might want to do in that sense is this is all the left femur, but you'll notice if we do separate shells to parts, Now actually we'll put the cylinder into two, put that part that is not connected into a separate part. The piece of the left field that's floating, so we can do connections between just those two parts as well. And then it will connect it. So we can again Boolean all the cylinders together, do the same thing. Just have one part that's all cylinders. If we want to make that easier, we can also duplicate any parts that have multiple pieces before we separate them. And that way, once these cylinders are made, we can just delete those extra parts, and we don't have to worry about having them be the same color or needing to rename them like this. So first do a duplicate and separate shells to parts. All right, so now all the parts are 3D printable, not floating. So without porosity on the inside. All right, thanks for watching.